Hi everyone, my name is Jenny Morris. I'm a solutions architect at Elastic. Today I want to talk to you about Elastic Machine Learning. If you are an Elastic customer, you probably have used the Elastic Anomaly detection or have heard of it. A very quick overview, anomaly detection allows us to learn in an unsupervised way. We learn the behavior of data over time just by watching it. And then we get to learn the ins and outs, the daily patterns, the weekly patterns, and then establish normalcy of behavior by looking at data as a function of time. Then we use that information to build behind the scenes with statistical models that allows us to predict what is coming, whether or not that's expected or not. And if emerging data started to behave very unusual, we can flag it, integrate it with alerting systems to operationalize it. What I can update you today on anomaly detection is just how it is tightly integrated within Elasticsearch and Kibana throughout all of our solutions. SIM is a great example where we have about 25 out-of-the-box unsupervised machine learning jobs now. Things like looking for rare processes, suspicious logging activities. You can also create your own machine learning job, put the SIM label on it, and the results will work in SIM. In 7.7, if you're familiar with the detection engine, you also have the ability to select a machine learning job for your detection rules. And in APM, if you are looking for unusual durations for your APM data, it will show those right within the APM app for you. And in the Logs app, we introduced a new tab for message categorization. We tokenize the text within the messages and identify what a normal pattern looks like for a certain type of message. So for example, when you get a spike in a database error over time period, we're going to be able to show you within the UI of the Logs app. And all these, you don't even have to know. Then the fact that there is a machine learning job getting created in the back end. In 7.7, we've also added the ability in uptime management. We have an uptime app that is going out and checking status for different services. And we have one click button to track that with machine learning and look for anomalies within uptime and report on it. In the Metrics app as well, if you are using Kubernetes or Docker within our metrics and viewing them within the Metrics app, you will be able to see, is there a new pod that's coming up that's unusual? Is it acting differently than other pods? Things like that. So because machine learning is within applications themselves, we are bringing that information up through the different app UIs to make it a natural flow for our end users. So those are some of the updates on anomaly detection, and you will see more of that within Elasticsearch and Kibana. And if you think about it, anomaly detection was kind of easier. We have years of experience. We have one of the best anomaly detection platform where you can use it in so many different ways to learn about the patterns you're looking for. So this really falls under the category of unsupervised learning, meaning that it is data-driven. It is looking for a pattern and identifying that pattern. And when there's something unusual happening in the pattern, you score it and you're able to alert on that. You don't have to label what is normal, what is abnormal, the data will indicate that. But there is this whole another type of machine learning where you would actually want to use machine learning algorithm and to learn from your data in a supervised way. And this is where you want to label the data and say this is important, or this belongs to that specific category, and you can start doing predictions. Yeah, you can have your own algorithm to learn from your historical data and make predictions going forward with new data. So use cases for that, excuse me, something like language identification, fraud detection, and also things like user classification, We know what an admin user is. We know what a typical standard user is. We know what a machine application user is, and we can classify them. And in the Elastic context, supervised machine learning model is nothing but another Elasticsearch index. So there's 3 different types of models that we have out of the box right now. Outlier detection is where we are looking at clustering across all the features and figuring out what's normal across most of our data. How far are the outliers? So you look at distance, you look at the density of a normal cluster, and you can see how far away the outliers are. For regression, this is where you're trying to predict a value. Let's just say a numerical value, whether it's a price or a byte count. And then we have our classification model, and you are trying to classify whether it's true or false, if it's in one category or the other, and that's a binary classification. And also, there is a multiple classification. This is where maybe you're trying to fit into like a standard user, admin user, light user, machine application user. So that's multiple classification. Typical use cases that you use Elastic solutions for search, machine learning models are commonly used for language identification, relevance, or recommendation engines. In observability use cases, we probably wanted to know what the unusual users or hosts are, who is acting unusual compared to normal behaviors. Also, a lot of customers suffer from alert fatigue. So being able to have second order classification to figure out what is an important alert, what that looks like versus just common alerts, so we can start to classify them differently and determine how they get routed. For security use cases, you can classify things like domain name information, building models for identifying domain names. That looks like it's generated from their DGA, domain generated algorithm. So we can predict that and block that type of data. And another security use case could be to classify the data by telling where it is come from, what types of devices that we think this data is coming from. So that was all good, but you may wonder, well, how is Elastic machine learning different than other, supervised machine learning different than other supervised machine learning tools out there? Because there are so many tools out there, including cloud tools from Google, Amazon, Azure. So one thing that we have been consistent on is that we really have been focusing on making machine learning easier to operationalize and simplify data science. Because it is one thing to be able to build a model, a machine learning model. It is another thing to put that model into production. And this is because an algorithm is just a small piece of what machine learning data scientists have to deal with. And there's a whole another talks around data collection, transformation, making sure you have the right data set, testing different models, verifying those models against new data, server infrastructure, resiliency, all that work, which is like 90% of the work that we have, which has nothing to do with actual algorithm. That's why where a lot of the debt comes from, and you see this everywhere. You see it on paper, and this is a paper that's from Google talking about the technical debt, hidden technical debt in machine learning system. And you see it on paper, you see it on blogs, and you go to data science conferences, and everybody talks about how operationalizing and launching machine learning can be very challenging, and also maintaining them is even more complicated than they ever imagined. So just to illustrate that operationalizing machine learning is hard, and it's because there's a lot of steps and a lot of tools. And these are some open source ones folks use to deal with logs and metric data. And then data scientists use Jupyter Notebook or scikit-learn to build their models and test their models. And they might be trying to connect to Spark to stream data. Of course, like I mentioned before, they may be using a lot more tools, but it's just different pieces that folks are trying to tie together, weave together with their own Python code and move the data around and build their own machine learning platform to solve their problem. It is just difficult. And that is a big driver for Elastic, right? Is to be able to simplify that process. Because everything we build it into the stack. We have the APIs, everything is tightly integrated with Elasticsearch and Kibana, so you can really leverage the power of Elastic Stack. And earlier we talked about how anomaly detection was so easily to operationalize, and we stay consistent with supervised machine learning. Really, allow the users to streamline the end-to-end experience. So now data scientists can import data into Elasticsearch. They can build their transforms, and they can run their models in Elasticsearch and simulate ingest the pipeline. So they will have this really nice end-to-end experience of building and putting machine learning in operation. And if you already have a model that you developed in Python, you can just plug that into our inference processor, right? So because this tool is already yours, you're a customer, right? You have access to this tool that we provided. But by leveraging Elastic Stack machine learning, you can easily operationalize whatever the model, right, the machine learning model, and you can quickly move to the next part of your job. And your organization can become more efficient, innovative, with a shorter time to market. Again, Elastic Stack is now delivering an end-to-end machine learning pipeline, providing a path from raw data to building, testing, deploying machine learning models in production. So that has always been our design philosophy, which is to help customers make it operational, make it ready, and bring down the total cost of operating machine learning. If you would like to learn more, check out the blogs and the webinar links I listed below. And please do let us know if you have any questions, or if you would like to try things out in our cloud environment, we could help you extend your 14 days trial into a 30 days trial, so you can have extra time to get your data into Elastic and build your machine learning models and operationalize them. Thank you very much and enjoy.